Hello. It's Matefaro here again, ladies and gentlemen. Welcome back to my space. Without wasting much time, let's move on with the next question in this problem set. We're still talking about domain and range, and this time around, we want to find the domain and range of f of x equals to 1 over square root of x minus 3. In the last video, I introduced the concept of domain and range. I said domain is the set of all valid input values. Okay, and for fractions, we've seen that the denominator must not be equal to 0. But what about when we have a function that is a radical? So when we have g of x to be equals to square root of anything, this function is only valid, is only defined when the anything is greater than or equal to 0. The square root function recognizes 0. It recognizes positive numbers, but it doesn't recognize negative numbers. So if we had a function h of x equal to square root of x minus 3, the domain is just going to be equal to the set of values for which x minus 3 is greater than or equal to 0. That is the domain of h of x. Okay, this is a bad set builder notation, but at least you understand what I'm talking about. And that is the set of all x in real numbers such that x is greater than or equal to 3, which we can write as 3 to infinity. So notice I've used a bracket here because of the greater than or equal to. If it were to be just greater than, then it would be a parenthesis. Okay, but in this case, f of x equals to 1 over square root of x minus 3. So there are two things we want, or let's say we don't want. We don't want 0 in the denominator. So because it is a fraction, we cannot divide by 0. So we don't want square root of x minus 3 cannot be equal to 0. And also, we know that when we have square roots, for this to be defined, x minus 3 must be greater than or equal to 0. But since we don't want 0, it has to be the strict inequality. So it means that the domain of f of x in this case is just the set of real values x such that, this should be 0, such that x minus 3 is greater than 0, strictly greater than 0, and that is x, real values x such that x is greater than 3. So 3 is not among all real numbers that are greater than 3. And we can write that in interval notation as 3, infinity. So simple as that. What about the range? What's the range of f of x? There are different ways to think about the range of f of x. Okay, but in this particular video, we're just going to think about it as, let's analyze what the output can be. Okay, so in this case, since the square root function is a positive function, okay, basically it's a non-negative function because we can get 0 and we can get positive numbers. So let's write that down. Range of f of x. So observe that square root of x minus 3 is always going to be positive. So it means f of x will always be positive. Okay, so that is one thing we know, but we don't know whether it starts at 1 or whether it starts at 2, whether it starts at 3. We know that it is greater than 0, but we can go back to the trick that we used the other time. So if we say y equals to 1 over square root of x minus 3, can we try to make x the subject of the formula? The answer is yes. But in doing so, we have to remember that we are also including some extraneous solutions. We are including some guys that are not supposed to be there. But let's do that. So if we take the square of both sides, we get So taking the square of both sides, we get y squared equals to 1 over x minus 3. And if x minus 3 and y squared swap places, we have x minus 3 equals to 1 over y squared. And that implies that x is equals to 1 over y squared plus 3, which is nothing but 3y squared plus 1 over y squared. So the usual tactic is to look at what you get when you make x out of the formula and try to find the values of y that will make that function defined. In this case, we can clearly see that it's a fraction. So the denominator cannot be 0. So ordinarily, the set of y values should be, so y should be all real numbers, except just 0. 0 is the only one that will give us problem here. However, we already have an information about y. F of x is y, of course. We know that y can only be greater than 0. So if we are saying y should be all real numbers except 0, and we also have this limitation, combining these two together, we get that the range of this f of x, okay, so should be 0, infinity. So let me break that down again. The two things that we know. So f of x, the output, we have seen that it has to be greater than 0, since square root of x minus 3 is greater than 0, because x is greater than 3. And so that means that is the first part. We have 0, infinity, and in the second part, we have all real numbers except 0. So we are looking at negative infinity to 0 union 0, infinity. So these are the two conditions that are on the range of f of x. So we got this part from analyzing the function itself. We know that it is not possible. There is no value of x that will give us a negative number. It's not possible, okay? Because the square root function will always give us a positive value in its domain, okay? So then the second part is gotten from using our usual trick of getting the domain of the expression you get when you make x the subject of the formula. And when we make x subject of the formula, we get this rational function that has y squared in the denominator. And since we cannot divide by 0, it means in this expression, y cannot be 0. That is the only problematic number here. So it means the domain of this expression here is all real numbers except 0. That is 0, negative infinity, 0 union 0, infinity. So when we combine, that is why I've used intersection. When we combine, because it must satisfy both of them. When we combine these two limitations, these exceptions, we get that the range. So when you do the intersection of these two, you get just the positive number. So the range of f of x, in this case, that is the range of 1 over square root of x minus 3 is equal to 0 to infinity. And that is the end of that. So remember, the key note to take here is the fact that the domain of a function is the set of the valid inputs that the function can take, while the range is simply the collection of the possible outcomes of the function. And for a fraction, for a rational function, to get the domain, you simply look at the values of x for which the denominator will be equal to 0. Once you have your hands on that, you remove those from the real numbers. What you're left with is going to be the domain. If you have a function that has a square root in it, you look at what is underneath the umbrella of the square root. you set it greater than or equal to 0. That is what I've written here. And when you solve that inequality, whatever you have is the domain of the function. And sometimes, like in this function that we're given, these two things can be combined, a fraction and a square root. So we combine them and we look at how to get the range. And one important tactic to remember in looking for the range is that the range of a function is the same as the domain of its inverse, if the inverse exists. If the inverse does not exist and we can actually make x out of the formula, we look at the expression we get when we make x out of the formula and find the values of y for which that expression makes sense. And that is going to be our range. So this is a good place to stop. Now, I think we're going to come back and continue with the next question, 1C. I think I can actually manage to do 1C and D together in the next section. So until then, enjoy mathematics and have fun. Bye.